Okay, so in this portion of the discussion, we are going to show you problem solving of compound interest and credit card bills problems. Okay, so here we are asked to solve for or to calculate the compound amount or the future value. And we are given with the principal, which is equivalent to 4,000, that is deposited in an account earning 6% interest. So that's my R. Compounded monthly. So there are 12 compounding periods in a year for 2 years. So my T is 2. So writing the formula, I'm solving for the future value. So my A is equivalent to P, 1 plus I raised to the big N. Okay, so P is $4,000. 1 plus, I don't know my I yet. My I is R over N. 6% is my R. In decimal form, it's 0.06. And N is the number of compounding periods in a year. Since compounded monthly, the interest is compounded monthly, 12. There are 12 months in a year. If I divide 0.06 by 12, 0.06 divided by 12, I would get 0.005. So in your calculator, it might have appeared as 5 times 10 to the negative 3. That just means you have to move the decimal place 3 places to the left. So 5, your decimal place is right here. So 1, 2, and 3. So you will get 2 zeros before 5. In some calculators, it would be 1 over 200. Just click the S to D button above the delete function to get the 5 times 10 to the negative 3. And the 5 times 10 to the negative 3 just means you have to move the decimal places 3 places to the left. So 0.05. Okay, how about my big N? It's just the product of small n times t. My n again is 12. My t, how many years? 2 years, so 24. So 1 plus 0.005, and then raised to the 24th power. So obviously this is 1.005 raised to the 24th. If I get this, if I solve for this 1.005 raised to that exponent, what I should be getting is 1.005 raised to 24 is 1.127159776. So I put all of the decimal places just to be sure. Multiply that by 4,000 times 4,000. I would get 4,508.64. That's the future value of my money. So again, this is just approximation since we rounded off to decimal places. Okay, so now you are asked to compute for the future value. Again, this is just the same as the compound amount. Your principal is 2,500 and the R is 9% compounded daily. So 360 times 360 compounding in a year for 4 years. This is my T. This is my R. Formula is A equals P1 plus I raised to the N. I is R over N. This is my N. 0.09 divided by 360. So if I do that, I would be getting 0.00025. So it might have appeared as in your, if you are using a scientific calculator, it might have shown you 1 over 4,000. Just click the S to D function above the delete function and it will reveal a scientific, the value in scientific notation. 2.5 times 10 to the 4, it just means you move the decimal places 4 to the left. 0, 0, 0, 1, 2, 3, 4. Sorry, it ends right here. So it's equal to 0.00025. My big N is just small n times t. N is 360. Time is 4. So 360 times 4 is 1,440 days, or 1,440. So P is 2,500. 1 plus I is 0.00 3 zeros after the decimal point, raised to the 1,440. So obviously this is 1.00025 raised to the exponent. So if we did this first, 1.00025 raised to 1440, I would be getting 1.433264,927. I put all the decimal places, no? I multiply that with 2,500, and I will be getting the future value $3,583.16. Okay, so right now I'm asked to compute for the interest rate, the compound interest. How much interest is earned in 6 years? So how much interest is earned in 6 years? This is my T. On $8,000, this is my P, deposited in an account paying 9% or 0.09. This is my R, compounded monthly. So my N is 12. 12 compounding periods in a year since monthly ang compounding. So A equals P1 plus I raised to N. We compute for A, and then we later use that to compute for the interest. Interest is A minus P. Interest rate, we are solving for the interest, not the interest rate, rather, sorry. Let's compute for the I. I is R over N, so 0.09 divided by N, which is 12. That would be 0.0075. Big N is N times T. N is 12, and T, how many years? 6, so 72. A is P, is equal to P, 8,000 times 1 plus 0.0075 raised to 72. Now this is of course 1.0075 raised to 72. This is in dollars. Okay, let me just check. 1.0075 raised to 72 is 1.712552707. So again, I put all of them. I did not round off. Future value is 13,700.42. Now this is just an approximation since I rounded up to 2 decimal places. This is not yet my final answer. I'm looking for interest. So my A is 13,700.42. Subtract that by 8,000. My interest will be 5,700.42. Okay, now I'm computing for the present value. My present value formula is A over 1 plus I over big N. How much money should be invested in an account that earns 9% interest compounded semi-annually? So my N is 2. There are 2 6 months, 2 semi-annuals in a year. in order to have $20,000 in 5 years. In 5 years' time, you want to have this future value. This is my A. 20,000 in 5 years. That means this is a future amount. So I need to solve for the present value. How much do I have to invest today to get 20,000 in the future? So again, the routine is I equals R over N, 0.09 divided by N is 2. So this will be 0.045. Big N is small n times T. N is 2. T is how many years? 5 years. So 10. So A will be $20,000 divided by 1 plus I, 0.045. Be careful not to add too much zeros. Raise to the 10th power. So let's just copy the dividend. This is 1.045 raised to 10. Now what is that? That's equivalent to 1.552969. What are the other places? 552,969,422. Okay, we use that to divide. We divide that, or we divide 20,000 with that, 1.552969,422. What we have is 12,878.55 rounded off. So here is my final answer. So if I want to get 20,000 in 5 years' time with this interest rate, I need to invest about 12,000 today. Okay, so now we have the effects of inflation on prices of goods. So assume that the average new car sticker price in 2008 is 28,000. Use an annual inflation rate of 5% to estimate the average new car sticker price in 2025. So if you're a little bit confused which one, what you are computing in the case of inflation problem, are you computing for present or future value? Just look at the time periods. You have an amount of 28,000. You are considering an amount of 28,000 today in 2008, and you want to know what would be the value of that money in the future. So that means you are computing for the future value in 2025, or you are computing for A. So your formula would be A 1 plus I rather raised to the big N. So the effect of inflation on prices of goods, you are asking for the future value. So again, I is, what's the annual inflation rate? So 5%, 0.05. My N is 1. N is always 1 in inflation problems since we want to simplify it. Big N is, since N is 1, it's just equivalent to T. The number of years is, okay, how many years are there in between 2008 and 2025? How many years in 2008 and 2025? 17 years. So how much is it today? 28,000. I want to know how much will it be in the future in 17 years time. This is in dollars. Okay. What is 1.05 raised to the 17th? It's 2.292018,318. Multiply that by 28,000, 2.292018,318. So I am approximating 64,176.51, rounded off to the two decimal places. Okay, how about the effect of inflation on the purchasing power of an insurance? Suppose you purchase an insurance policy in 2010 that will provide you with $500,000 when you retire in 40 years. So obviously, this is a future amount since you are getting the amount in 40 years' time. That would give you a clue, that should give you a clue that what you need to compute is the present value. Assuming an annual interest rate of 7%, what will be the purchasing power of $500,000 or this much, $500,000 in 2050? So I am computing for P, A equals 1 plus I raised to the big N. So I is R over small n. Again, very simple in inflation, N is 1. So I is just equivalent to the annual inflation rate. Big N is N times T, 1 times how many years in between 2010 and 2050? I think 40. So 40 years. So $500,000, if you want to receive this much by 40 years, how much do you have to invest today, given the inflation rate 7%? If you want to get this purchasing power, 1 plus I, 0.07, capital N is 40. Okay, let me just compute for the denominator. 1.07 raised to 40. 14.97445784. Okay, so $500,000, half a million, 1497 divided by this, 5784. Okay, I am getting an approximation 33,390.19. I have to invest. Oh, no, no, no. This is the purchasing power of the half a million in 40 years' time. Not how much I need to invest today. That's a different problem. Okay, last and finally, this is an example on credit card bill. So you need to prepare a table, right? So you have a bill, an outstanding balance of 1,024, which you weren't able to pay during the due date July 1. You made a purchase of $315 on July 7 and another one on July 22 amounting to 410. You made a payment during the middle of July, July 15, amounting to $400. If the interest is 1.2 per month, what is the finance charge on the next bill, which is on August 1? So the first column should be the date. Okay, I have a bill on July 1. I wasn't able to pay. My next purchase was July 7. So the first dates should be from 1 to 6. July 7, I made a purchase. I made a payment July 15. So this should be 7 to 14. July 15, I made a payment. I made another purchase 22nd of July. So 21. 15 to 21. July 22 until, do we have a 31 in July? January, February, March, April, May, June. Yes, we do. 31. Right before August 1, the next bill. Okay, so payments slash purchase. That's my next column. I didn't made any payments or purchase on 1 to 6. On July 7, I made a purchase. So a positive 410. I made a payment, so that needs to be subtracted from my bill, minus 400. And then July 22 to 31, I made a purchase of 410. Okay, I'm sorry, I made a mistake. I made a purchase on July 7, 315. balance each day. How much is my outstanding balance? I wasn't able to pay 1,024 before or on July 1. So I need to add that with my purchase on July 7. So 1,024 plus 315 is 1,339. I made some payment, so I need to subtract that 939 and then add another 410 since it's a purchase 1349. So this is my outstanding balance. Number of days 1 to 6 is 7 days or 6 days. 6 minus 1 is 5 plus 1 6. 14 minus 7 is 7 plus 1 8. 21 minus 15 is 6 plus 1 7. 31 minus 22 is 9 plus 10. Okay. Unpaid balance times number of days. So 6 times 1024, 611, 6144. 8 times 1339, 10,712. 7 times 932, 6,573. And 10 times 1,349, 13,490. So my average daily balance is just the summation of this. 36,919. That's not yet the final answer. No. This is not yet my average daily balance. I need to divide that actually by the number of billing dates, the number of days in the billing period. So I made the purchases during the month of July. July has a 31, or there are 31 days in July, so my divisor should be 31, 1,190.94. This is my ADB, average daily balance. So finally, my billing charge, not billing charge, finance charge on my next due date will be equivalent to IPRNT. My principal is my ADB, 1190.94. So the interest per month is 0.012 and times 1 since I'm computing only for the period of July. So 1190.94 times 0.012 times 1 is 14.29. That's my finance charge on top of the outstanding balance 1,349.